Hey guys, today we're going to start looking at your final exam practice. So these questions don't mirror exactly what you see, but this is good for the front page of your practice test, questions 1 through 5. First thing we want to do is look at radical equations. Specifically, we're going to graph, talk about domain and range, find some shortcuts to do with that, and also talk about transformations, because we remember the transformations were all going to be the very important parts of this course. So the first thing we want to do is sketch the graph. Whenever I have to sketch a graph, I want to see what kind of radical symbol do I have. It's a square root or a cube root. In this case, I see that that is a square root. There's no index there. And I remember that square root functions take this kind of shape. So I know that's what my graph should end up looking like. That's going to help me out big, right? And so the next thing that I can remember then is that it's going to have this as my parent function. So this is going to be for letter A, where we are graphing this function. And I'm going to draw my xy table. And the parent function points start off with x values that I can take the square root of. So that's 0, 1, and 4. I can take the square root of 0, and that's 0. Square root of 1 is 1, and then the square root of 4 is 2. Now, the next thing I have to look at is what is the h value. Okay, so h is -1. And that means I'm actually going to be breaking the rules and changing that sign. So it's like I'm changing the x values by adding 1 to each one of those. So 0 plus 1 is 1, 2, and then finally 5. Okay, so those are my new x coordinates. Next thing I look at is what's my k value. Well, the k value is -4. Okay, so with -4, then that means I'm going to be shifting down. And then I also have the a value here, where a is equal to 2, and that's our vertical stretch. So what we want to do first is our vertical stretch. That's multiplying by 2. 0 times 2 gives me 0. 1 times 2, gives me 2. And then 2 times 2 gives me 4. Next thing we are going to do is the moving down by 4. So that's subtracting 4 from each one. 0, -4. Or 0 minus 4 is -4, 2 minus 4 is -2, and 4 minus 4 is 0. So now I've got all my key points that I need. Okay, and we can go ahead and graph. The first point is 1, -4, that's right here. And then we have 2, -2, and 5, 0. And I remember that shape that I drew before. It's going to be a nice smooth curve, but it's going to be moving up and to the right. So there's the sketch of the graph. Okay, the next thing that I can look at is part B. And part B, I'll go back up here, it says to find the domain and the range. So domain is the set of all possible x values. Well, there's a quick shortcut with this. I'll show you in a moment. But let's take a look at the graph. Domain is talking about going left and right. Okay, so I don't want to be moving. I'm not going anywhere to the left after a certain point. I'm always going to the right. But where do I start going to the right? That's at that x value, +1. So the domain is going to be x values that are all greater than or equal to 1. The range is when it starts going up and down. Now, I'm not going down any further past this starting point, but I am going up. So here, my range is going to be y values that are all going to be greater than or equal to that y value, and that is at -4. Excuse me. There we go. So my range is all y values that are greater than -4. Okay. Now, the quick way to recognize this is that we can see that our h value is going to be closely related to the domain. So real quick, without the graph, you can see just change the sign of h, and that gets you your domain. And then k, you don't need to change the sign. That's going to point you to the range. Okay, and that's going to be true for all of these square root functions. The next thing that we can look at is part C, and that's where we have to describe the transformation of the parent function. Okay, transformations, remember that's these a, h, and k values. So that's these guys right here. So for part C, it says, okay, well, we remember that when h is negative, that means we are shifting to the right. So we went right 1, and then we did the a value, that was a multiplication by 2 to all the y values, so that's a vertical stretch by 2. And then finally we had the k value of -4. So that told me we were moving down 4 units. Done and done. Okay? So that's that. That's all we have to really think about for square root functions. And we'll go a little bit quicker this time where we start to look at this next one. So for this graph, it's the exact same instructions, except now we've got a cube root function. Cube root functions, where the index is 3, follow this kind of S-curve shape going to the left and right. So here's what we want to take a look at then. Let's go ahead and talk about what numbers can we take the cube root of for our parent function. I can take the cube root of some negative numbers like -8 and -1. I could take the cube root of 0, and then I could take the cube root of +1 and +8. Then I start to think about, well, what was the cube root of -8? That's -2. Cube root of -1 is -1. Of 0 is 0. Of 1 is 1. And of 8 is 2. So that's my parent function for all the cube root functions. Now let's go ahead and identify what each of the different transformations are. H is a +5, and we remember that that means that it's going to be going to the left. So H is 5. K is a +1, so that's like going up. And then we have the A value is a -3. So that means we do have a vertical reflection as well as a vertical stretch. So we've just described in words part C. So part C is essentially done for us just by recognizing those things. Now let's go ahead and make the transformations to make our graph. If we are moving to the left, that means we're subtracting 5 from all the x's. So that's going to be -13, -6, -5, -4, and a +3. And then we always want to make sure we start off with the A value. So that's multiplying by -3. That's going to give me 6, +3, 0, -3, and -6. And then we are going to move up 1. That's by adding 1. Adding 1, we end up with 7, 4, 1, -2, and -5. So those are my points that I'm going to plot. -13, 7 is obviously off the graph, so I need to just move on to my next one. -6, 4 is going to be up here. -5, 1 is going to be right here. -4, -2 down here. And then finally 3, -5 is going to be way over here. And that doesn't really look like that S curve that we saw before, but remember that -13, 7 is going to be somewhere like way over here off the graph. And now I can start to see that S curve, except it's been flipped. Well, that was because of the A value that we had. That vertical reflection actually also flipped the shape of the S curve. Okay, so there's our graph. Now we can take a look at part B. Part B, again, is for the domain and range. So my domain, we look to see where does this graph stop going left or right. And it doesn't. And we remember that it's really easy to say all of that. We can say that x is going to be equal to all real numbers when the graph goes forever in the left or right direction. Same thing with the range, except we're talking about the y values. Well, the graph is going forever left and right, but it's also slightly still going up and down, and it never stops. So my range for all cube root functions will also be all real numbers, but it's for the y values. Then finally, the last thing that we have is part C, describing the transformations. Well, we did that a little bit with our arrows. So that is a left shift of 5. We had a vertical reflection or reflection across the x-axis. We also had a vertical stretch by 3. And then we also went up 1 unit. Okay? So that's it. That's how we end up graphing cube root functions, describing their transformations. We can also see pretty quickly the shortcuts for square root functions too by looking at just the h and k values. So utilize that to answer the questions on your first page.